Oh, you're watching 8.3 special right triangles, 45, 45, 90 for geometry. In this lesson, you will be practicing the Pythagorean Theorem, and we will be discovering patterns of isosceles right triangles, which end up being 45, 45, 90. So we're going to use Pythagorean Theorem in this first section to find the missing side lengths. So we're going to discover how the 45, 45, 90 triangle relates to that Pythagorean theorem. We do not want decimal answers, so we want it in simplified form at all. We learned back in the last unit that if you have markings on the sides of a triangle, that means those are congruent, which means the same. So if this side is 3, this side is 3. If we go to the Pythagorean theorem and we do 3 squared plus 3 squared is equal to a squared, that is 9 plus 9 is equal to a squared. 18 is equal to a squared. Root it, and you can break your root up because it needs to be perfect, to 3 root 2. So this side is 3 root 2. Over here, same thing happens. This side is 4. So we get 4 squared plus 4 squared is equal to b squared. You get 16 plus 16 is equal to b squared. This is 32 is equal to b squared. Root it and root it. Break it up, and you get 16 and 2 for b, which ends up being 4 root 2. Okay, hopefully I'm not going too quick for you. Next one. Same thing. Looks like the sides are 5 this time. So in this case, we'll do 5 squared plus 5 squared equals c squared. This gives us 25 plus 25 is equal to c squared. 50 is equal to c squared. Root it and end up with 25 and 2. So this answer is 5 root 2. I'm hoping that you're noticing a pattern right now, because we chose these questions for you to be able to discover the pattern. And the next one is a right triangle. These sides are congruent again. So we end up with 6 squared plus 6 squared equals d squared for Pythagorean theorem. 36 plus 36 equals d squared. 72 is equal to d squared. Root it, and you could get a 36 times 2 gives you the 72 for 6 root 2. Did you notice the pattern yet? Take yourself a second here. So in the right triangle, the isosceles right triangle with the sides of 3, the hypotenuse was 3 root 2. In the right triangle isosceles, the sides are 4, 4 root 2. When the right triangle isosceles was sides of 5, 5 root 2. In the isosceles right triangle, sides are 6, 6 root 2. If I go down without actually doing any work here, if the sides are 7, what should the hypotenuse be? 7 root 2, you're right. And in this one, we're looking at the triangle here. So it's isosceles right triangle. Sides are 8. So the diagonals here should be 8 root 2. So the pattern, hypotenuse is 3 root 2. Hypotenuse with sides of 4 root 2. 5 root 2. 6 root 2. 7 root 2. And 8 root 2. This is the hypotenuse. What do you know about the acute angle measure of each of the following triangles? So in the following triangles, what do you know about those acute angle measures? Well, you should know that the acute angles are the same. And how do you know this? Well, because you learned a theorem that says if the sides are congruent, then the angles across from those sides are congruent. So this angle would be congruent to this angle right here, giving you, because we know 180 degrees is in a triangle, if one of them is 90, you're left with 90, and they have to be the same, so you can divide by 2. 45 and 45 are left over for those other two. So if you were given this generic one and the side lengths were n, the hypotenuse then has to be n root 2. Hopefully you got that pattern. So it's a blank triangle like you have there. N, N, and n root 2. Okay, so let's just jump into this. If we were doing this pattern, find the length of the hypotenuse. We know that this side has to be 15 centimeters. So this side has to be the n root 2 side. So it is 15 root 2 centimeters for the answer. If this is the side and we want to find the side lengths, this is the n root 2 side. So you can take 21 root 2 and divide it by the root 2. They cancel out. So 21 is the two side lengths that we have. Question 3, find the missing side lengths. Once again, you notice that this is an isosceles because it was a congruent right triangle. So B is 45, C is 45, A matches with the 12 over there, and if these sides are 12, you know this is 12 root 2 meters. Next question, 8 root 2, we want to find the perimeter, so be careful, find the perimeter. So that means we're going to get all the sides and we're going to add them up. The 8 root 2 side is the n root 2 side. So you're going to divide by root 2, and 8 is equal to n, meaning the one length is n, the second length is n, add them all up, 8 plus 8 plus 8 root 2. I don't want to see that you combine those. These two can be together. So your final answer is 16 plus 8 root 2 centimeters. Okay. Number 5. What is the area of the square? Well, first off, let's talk about what the area formula for the square is. So you have s squared is the area, or length times width, which is the same thing, okay, for the square. So when we're looking at this, once again, this is the isosceles right triangle, so these would be 45, 45, 90. We can take this side length of 19 root 2, okay, meaning that if we're looking at the triangle, so the 19 root 2 is equal to the n root 2 side. So we divide by root 2's, and 19 is each side length. So they asked for what is the area. So you take 19 times 19, giving you an answer of 361. We needed some units, and we're going to square it because area is squared. Excellent. 6. What is the perimeter of the square? So, once again, we're looking at this isosceles right triangle, which is a 45, 45, 90. The 6 root 2 side is equal to the n root 2. You're going to divide by the root 2. They cancel out. 6 is equal to n. Each side length is 6. Instead of multiplying them together this time, you're going to take 6 plus 6 plus 6 plus 6. So it's 24 units of measure. All right, number 7, find the missing side lengths. So now, you're still noticing, and nothing has changed on this unit. It's 45, 45, 90s. So this is the hypotenuse side, right? So that means the 8 root 10 is equal to the n root 2, which means you have to divide by root 2. They don't cancel out anymore. But what they do is that you can look at it and you can say, oh, the 10 and the 2, so we're going to have to multiply the top and bottom by root 2. So we get 8 root 10 root 2. So we're going to times root 2 over root 2. So this is 8 root 20 over 2, which then ends up being 4 root 20. And we're able to break that up into 4 and root 5. So it's 4 times 2 times root 5, which is 8 root 5. Okay. Good so far? Okay. Next one, find the missing sides once again. So if we're going to find the missing sides over here, we're going to take this side being 4 root 3, and then we know that this side is the n root 2 side because this is the hypotenuse side. So we're going to take the 4 root 3, and we're going to times it by root 2 this time. So we get 4 root 6 centimeters for the missing side. And last but not least, find the length of the legs. So this is the hypotenuse side, which is the n root 2 side. So 12 is equal to n root 2 divided by root 2, and you have to leave 12 over root 2. So you multiply top and bottom by root 2 over root 2. So we get 12 root 2 over 2, which reduces to 6 root 2 in inches. So this side is 6 root 2, and this side is 6 root 2. And last but not least, we have the hypotenuse side again. Find the missing legs. So this side here is the n root 2 side. So 22 is equal to n root 2 divided by root 2. So 22 divided by root 2. Got to rationalize it, so multiply top and bottom by root 2. So 22 root 2 over 2, which is 11 root 2 inches for each side. This just takes us to the end. I hope that you found it. I mean, memorize the triangle, understand where it came from. All this stuff will help you with a better math background if you are practicing and you are putting forth that effort. So good luck to you with the rest of the unit.